Okay, good morning Year 10. Welcome to your next lesson using prime factor decomposition. Yesterday we used prime factor decomposition to find the highest common factor and lowest common multiple of two numbers. Today we're going to use it to find accurately square roots and to also find out missing factors to make square roots. Okay, first thing I want you to do is I want you to pause the video now. I want you to calculate the prime factor decomposition of the three numbers you see in front of you. So can you please find the exact prime factor decomposition of 144, 400 and 1156, and then we will go through. So pause now and have a go at that for me, please. Okay, so let's have a run through. Right, 144. Now we're going to look at bigger numbers today. Okay, so we've got quite big numbers to work with. So when it comes to doing the prime factor decomposition, we need to be accurate and we need to play a bit smart with how we do this. Always the first thing I try and do is get the number small before I worry about any other factors. So we always look at 2s, 5s, any numbers like that we know easily go in, and we can work from there. Okay, so 144 I know is even, so 2 will definitely go in as one of my prime factors. So it would be 2 times 72. 72 definitely isn't a prime factor. So we can go 2 again, because I know it's even, and 36. Again, 36, definitely not prime, but it is even, so I can split to 2 again. And I will go 2 and 18. Still even, so I just keep halving. So I get to 2 and 9. 9 can then be split into 3 and 3. So we should have our prime factor decomposition as 2 times 2 times 2 times 2. Times 3 times 3, 2 to the power of 4, times by 3 squared. Okay. Quick look at 400. So 400 again, I know I can do 2, it's even, so I'll go 2 and 200. We can then go 2 and 100. I'm just going to keep using 2s while I can to get me nice and small. So I'll go all the way down to 2 and 25. 25 should be nice and easy, 5 and 5. So 400 will become 2 times 2 times 2 times 2 times 5 times 5. So we'll have 2 to the power of 4 times 5 squared. So 1156. Definitely a little bit harder, and you may have missed the last pair, but you've always got to double check. Okay, so 1156 again we know is even, so we can go and split using 2, so it'll be 2 and 578. 578 again even gives me 2 and 289. Now 289 is one of the more difficult ones. It is not a prime number, but it also doesn't have particularly low factors. 289 is actually 17 squared. Now I know that's a little bit more difficult, but you have to be aware of it and keep checking these numbers. So we should have 2 times 2 times 17 times 17, which becomes 2 squared times 17 squared. Okay, now if we look at all of the ones we've just done, so we've got 2 squared times 17 squared. We've got 2 to the power of 4 times 3 squared, and 2 to the power of 4 times 5 squared. Now, all three of those numbers are square roots. Okay, and the way we check for square roots is we think about what the properties of a square root is. Now, the square root means we times something by itself to get the answer. So when I'm thinking of my prime factors, what I want to do is I want to be able to split the factors into 2 equal groups. Okay, therefore I will have a square number. So for example, 2 to the power of 4, I can have a 2 squared one side and a 2 squared the other side, and then I can have a 3 one side and a 3 the other side. So I can split them into 2 equal groups. Okay, so I've got 2 to the power of 4, I can split into 2 squared and 2 squared. 3 squared, I can split into 3 and 3. because I can split them into two equal groups, it means it is a square number, so I can do the square root of it, and I can work out the square root of it. 2 squared is 4 times 3 is 12. 2 squared and 4 times 3 is 12. So the square root of 144 is 12. Okay. If we check it with the next one, 400, 2 to the power of 4 and 5 squared. Well, I can split my 2 to the power of 4 into two lots of 2 squareds. I can split my 5 squared into a 5 and a 5. Therefore, I'm confident it is a square number, okay, because I've been able to split my prime factors. I can then work out what the square root of it is. 2 squared is 4 times 5 is 20. Therefore, I have a square root of 20. The 1156, again, I can split into 2, because my 2 squared I can split into a 2 and a 2. My 17 I can split into a 17 and a 17. Therefore, I'm confident that it is a square number. Okay. I can therefore find the square root. 2 times 17 is 34. Therefore, 34 must be the square root of 1156. So we use our prime factor decomposition. We set it up into this form where we're using powers to simplify. And then all we've got to do is check to see if we can split those powers equally into two groups. Then we're happy it's a square number. Then we can see what the square root of it is. Okay. Now, using those examples, I now want you to have a go at this one for me, please. So can you try and find the square root of 784 using prime factor decomposition? Okay, so I want the square root 784 using prime factor decomposition. Pause the video and can you try that now for me, please? Okay, so 784. First thing to do is we need to do the prime factor decomposition of it. Okay, so always even number. So we're going to start with taking a 2 out. So we can go 2 and 392. Again, still even. So again, we're going to go 2 and we'll go 2 and 196. We're still even, so we're just going to keep using the 2s at the moment because it just makes it easier for us. Keep going with the 2s and we get to 2 and 49. 49, we should hopefully recognise quite quickly, is 7 and 7. So 784 should be 2 times 2 times 2 times 2 times 7 times 7, which will give me 2 to the power of 4 times 7 squared. To check it's a square number, I need to check I can split it into two equal groups. 2 to the power of 4 I can split into 2 squared and 2 squared. 7 squared I can split into 7 and 7. I'm therefore happy it's a square number. To find the square root, 2 squared is 4 times 7 gives me 28. Get that on both sides. So the square root of 784 will be 28. Okay. Now I've got some of those for you to have a go at on the worksheet. Just a couple of other things I want to go through with you first. So, other sort of things you might get asked is what you need. What's the smallest additional factor you need to add on to make these into a square number? So it's using that factor of being able to split them into two groups and what's missing. Okay, so first one, if I've got 2 times 2 times 2 times 3 times 3. Okay, now I would definitely want to go, right, that's actually 2 cubed times 3 squared. Okay, just simplify it. And then I'm thinking about my two groups. So my two groups, my 2 cubed, I'll end up with 1 on each side, but then I'm missing 1. Okay, and then I can put a 3 on each side. Now what I'm missing to make these even is I need another 2 in here. Okay, that's what I need to do to make the square number. So my missing additional factor will be that times by 2, because that's the bit I'm missing to make it so I've got even parts. Okay, right, pause the video. What's the additional factor to make the square number for question 2, please? So 3 times 3 times 5. Think about what the additional factor would be, please. Okay. First thing, just going to simplify it. Just because if you've got a really long one, it might make it easier to see. When I split in half, my 3 squared, I can split into a 3 and a 3, but I've only got 1 5. Therefore, to balance these up, I need another 5. So there's my missing factor, is the times by 5. Right, same again, guys. Can you please pause and can you do question 3 for me? So 2 to the power of 4 times 3 cubed, what's the missing factor? Hopefully we're beginning to spot these a bit quicker. Okay, so already simplified for us. We should hopefully be spotting these quicker now. 2 to the power of 4, I can split into 2 squared and 2 squared. 3 to the power of 3, I'm going to struggle with, because I can do a 3 and a 3 on each. Then I've got only 1 3 left. So I need that missing 3 again to become my missing factor. Again, it's just checking to see where these are even. The last sort of one you might get is, for example, 5 to the power of 7. Now, what we should hopefully be realising is we don't necessarily need to write all of these out to think about it. Because I need to split 5 to the power of 7 into 2 equal groups, I've just got the 5 to worry about. So I can just keep working my way across. What I have to have in order for this to work is I have to have even powers. If I don't have even powers all the way along, I'm going to struggle. So all this is missing to make it into an even power is I just need another times by 5. If I have another times by 5, that would become 5 to the power of 8, which I can then split equally. Okay, so finding missing values, missing factors to make into square numbers. Last bit I need you to think about very, very quickly on cube numbers. Now, it's very similar to find cube numbers and to find cube roots as it is square roots. If I give you 216 as an example, okay, we break it down into our prime factor decomposition again. Okay, so we go 2 and 108, 2 and 54, 2 and 27. Can't use 2 anymore, but 3 goes into it, so we can go 3 and 9, and 3 and 3. So I'll become 2 times 2 times 2, times 3 times 3 times 3. So I end up with a 2 cubed times a 3 cubed. Now to make it into a cube number, square numbers we split into 2 groups, cube numbers we just need to split into 3 groups instead. Okay, as long as we can get 3 equal groups out of it, it's a cube number, we can find the cube root. So my 2's I can split into 2, 2 and 2. My 3's I can split into a 3, a 3 and a 3. Therefore I'm happy it's a cube number, can find the cube root. 2 times 3 gives me my cube root of 6. Okay, do not worry about 1728, but it's exactly the same idea with cube numbers, it's just we're split into 3 groups rather than 2. Please make sure you've made any notes you need, get back onto show my homework and attempt the worksheet, please.